But in this video, we'll have a look at the real deal. And because I show you my own version of the experiment, there is a good chance that you will see aspects of it that you have never seen before. My version of the experiment uses slits that have a width in the order of only a few wavelengths of light, which is actually significantly narrower than used in most experiments. And we will study diffraction under a microscope instead of at a large distance on a screen. Now, this allows us to look at a few aspects of the experiment with much greater detail. So to perform the experiment, I made various slits ranging from 2.5 to about 25 microns. And in the experiments, I also varied the distance between the slits. So let me first show you what you actually see in the experiment, and after that, let's have a look at how the experiment works and how the images were made. Here we're looking at the cross-section of a laser beam showing the intensity distribution. And this beam is sent through two very narrow slits of approximately 3.5 microns wide. And this is what you observe after the light has passed the slits. It spreads out in these bright and dark bands, especially in the direction perpendicular to the slit. By the way, notice how the individual slits are not spreading the light as a uniform bump, and this is because of the scale at which we're observing. Basically, everything you see here happens within 1 cubic millimeter. You can see that the pattern of the individual slits already contain a lot of interference structure before the light starts to visually interfere with that of the other slit. As we move further away, the light of the two slits gradually starts to interact. Here at the bottom you see an intensity profile plotted, and this graph shows you the sum of intensities of the pixel columns in a part of the image above the graph. Now notice how the interference pattern develops between the slits. First here in the center, and later it spreads out over almost the complete extent of the pattern. You can actually measure that the interference pattern is quite different from the patterns you would get if you would just add up the intensities of the individual slits. What I show you here is all experimental and not just some simulation. And I wanted to show you this first to demonstrate that the double slit experiment actually contains way more fascinating details than are normally presented. In fact, even the single slit experiment is already pretty groovy by itself.